In this recording, we are going to be answering questions from OCR's Programming Techniques End of Unit quiz. I'm going to answer just one question in each video, so it's not too much content and you can work your way through it. What I also recommend is read the question before I go through the answers and see if you can figure it out yourself, and then check to see if you got it right or if you can do it better. So in our first question, we're starting with the very basics. Compare the use of variables and constants in a computer program, giving one similarity and one difference. So both variables and constants are types of data structures. They both hold data, but they hold them in slightly different ways, and that's an important difference to know. So I'm going to start off with a definition for both. So a variable is a named location in memory, also known as RAM, that holds a value, and this is the most important part, that can change whilst the program is running. So think about variable, think about the word vary. If something varies, it changes. Now a constant, if something is constantly the same, it doesn't change. So a constant is also a named location in memory that holds a value that does not change whilst the program is running. So just by writing those two definitions out, we've noted the biggest differences and the biggest similarities between the two. And let's just pull those out, let's abstract those from the answers. So a similarity are both refer to memory locations. When we talk about memory locations, think specifically of RAM and think about how RAM has lots and lots and lots and lots and lots of little locations in there, and we need to be able to know where we're going to be fetching data from in RAM, hence we need to store it in a named location that we can actually find. So both refer to memory locations. Both are given an identifier. So when you're writing your programs, you'll always name your variables with an appropriate name in the same way that you'll name your constants with appropriate names. And both are used to store data whilst the program is running. Now, the biggest difference between the two are variables' value can be changed, whereas a constant's value cannot be changed. Cannot be changed whilst the program is running. So a lot of repetition there for what would probably be a 2-mark question, but it is so important that you know the basic definitions for these two data structures. A variable is a named location in memory that holds a value that can change whilst the program is running, and a constant is a named location that holds a value in memory that does not change whilst the program is running. So let's move on to BI. A programmer creates the following code, and let's just go through it line by line. And I find whenever we look at code questions, that's the best way to approach it, because line by line you definitely understand what's going on, whereas if you look at it as a whole complex problem, it becomes a little bit more confusing. So we start off in line 1 where we're going to input y. So we are inputting a value that's going to be stored in y. X equals y mod 5, so x is another variable, and we're assigning the value of y modulus 5. So that's where we divide y by 5 and we store the remainder in x. Then we have a selection statement in line 3, so if x is equal to 0, then we're going to print true and we end the statement. So what it's trying to look at here is the difference between here where we have a single equal sign and here where we have 2 equal sign. So even when we're writing pseudocode, this is the kind of syntax or the kind of specific writing skills that we want to be really careful about, because it can make a big difference in terms of how the code is going to be interpreted. So in the second line, x is equals y mod. So that means that a single equal sign is an assignment operator. More specifically, it assigns a value to x. In line 3, and it's easy to remember if you think of an if statement always being followed by a comparison or a condition. So two equal signs is a comparison operator. And that's where we're comparing two values. We're comparing two values. So we're comparing the value of x, or the value held within the variable x, with 0. So one equal sign means it equals the value, and two equal signs means we're checking, is it equal to the value? Is it equal to the value? And you wouldn't get marks in this question for just simply rewording what is written in the code. You do need to be really, really explicit, talking about how a single equal sign is an assignment operator and a double equal sign is a comparison operator. Other comparison operators would include greater than, less than, greater than or equal to, less than or equal to, or not equal to, which can sometimes be written like that. Right, B2. What is one output that would, I'm going to assume they mean cause here, the program to output true, and explain why this is the case. So now it's actually checking our understanding of the code. So what is one input that would cause a program to output true? So what are we checking here? We need to see what could be input stored in y, that the result of y mod 5 would be equal to 0. So we're trying to find what could be input that would be divisible by 5 without leaving a remainder. So in this instance, any number that is a multiple of 5 would be acceptable. And we can be even more specific, where we would say any integer value, because it needs to be a whole number, that is divisible by 5. So it ends in 5 or 0. Always good to give an example, e.g. 35 mod 5 would equal 0, because 5 goes into 35 5 times with no remainders. If you want to explain it a little bit more, the value assigned to x needs to be divisible by 5 without leaving a remainder in order for it to be equal to, there we go, 0. In which case, if we change input 35, in that case, 35 mod 5 equals 0, then if 0 is equal to 0, this statement is true, therefore we would print true. Right, let's move on to BIII. What are two basic programming constructs that have been used in the code above? So when we're talking about programming constructs, there's usually 3 that we're talking about, and I'll usually remember them thinking SSI. Now the first one is sequence, and all algorithms have them. The second one is selection, and the third one is iteration. Now, sequence is the order instructions are executed. Now, all programs need sequence, otherwise they wouldn't run logically, because if the order is incorrect, the logic will be incorrect. Selection is when we can, or when the program can choose a different path. And the final construct is iteration, which is repetition. Repetition. And that's when a line or block of code is repeated a certain number of times or until a condition is met. And if we take a look at our code here, as said, there's always sequence in algorithms. So we can see that we need to execute line 1, then line 2, then line 3. And now we have a decision which can alter the path, because if this is true, then we execute line 4. If not, we go straight to line 5. So no code is being repeated here, but we are choosing different paths. So in that case, this code has both sequence and selection. So an easy way to remember if there's selection is if there is selection. If there's an if statement, then there is selection. BIV, so B4, what is the name of one programming construct that has not been used in the code above, and give an example of how this construct could be used. So I'm actually just going to go back to this one. And the one that has not been used is iteration, which is repetition. And how would this be used? Well, this could be used with either a for loop, which is a count controlled loop. And how could this be used? Well, we could use it to allow the user to continue inputting a number until the statement is true. And in which case, we would be using a while loop, which is a condition controlled loop. And let's read the question again. What is the name of one programming construct that has not been used in the code above? And give an example of how this construct could be used. So let's see what other examples we could give. Iteration, any reasonable example, e.g. use of a while loop or a for loop, any reference to looping or repeating the code. So we've said iteration is repetition, so let's be even more explicit here. Repetition of an instruction or block of